Hello and welcome to this continued lecture on subsetting in R. So partial matching is a handy tool which often saves you a lot of typing at the command line. It's not particularly useful when you are writing out programs and functions, but it's very useful when you are kind of working at the command line, typing things as fast as you can. So the idea with partial matching is that it works with the double bracket and the single and the $sign operator. So suppose I have a list X which has an element in it called aardvark, which is the sequence 1 through 5. And suppose typing out the word aardvark every single time is a bit of a pain. So I'm just going to type the word A. Well, the way the $sign works by default is that it looks for a name in the list that matches the letter A. In this case, there's only one element, and so you get the word aardvark. And then it gives the object associated with aardvark, which is the sequence 1 through 5. So if I use the double bracket operator, things will be a little bit different. So what the double bracket operator expects is that it is going to be an exact match for one of the names in the list. So by default, the double bracket operator doesn't do partial matching like the $sign does. So now what I pass X double bracket A, what happens is I get null back because there's no element of the list that has the name A. But there's a second argument that you can pass to the double bracket operator, which is the exact argument. And if you specify that exact equals false, and then when I pass at X double bracket A, it gives me the sequence 1 through 5 because that's the one that matches the letter A the closest. Last thing I want to talk about is removing missing values or NA values from an object. This is a very common operation in data analysis because most realistic data have lots of missing values. And so the way you can do this for either a vector or a matrix or a data frame is you want to create a logical vector which tells you where the NAs are, and so that you can remove them by subsetting. So here I've got a vector X. This is a very simple example which has the numbers 1, 2, 4 and 5. But then there are missing elements NA in the 3rd position and in the 5th position. So what I want to do is I want to get a vector back that's just 1, 2, 4, 5, the non-missing values. And I want to strip out the missing values so I can maybe do some computation. So the first thing I do is I use the is.na function to go through the vector and tell me which elements are NA, and I create a new vector which I called bad here. So bad is going to be a logical vector which tells or which is true if the element is missing and false if it's not missing. So even though I haven't printed it here, the bad vector is going to be a logical vector that has false, false, true, false, right? Because the 3rd and the 5th elements are missing. So now that tells me which ones are missing, but actually I don't want the ones that are missing. I want the ones that are non-missing. So I need to take the kind of the opposite of bad, which I can use with the bang operator or the exclamation point. So now I take X single bracket bang bad, and that gives me the good elements which are 1, 2, 4 and 5. So what if there are multiple vectors or multiple objects and each one has a kind of missing values in slightly different places, and you kind of want to take the subset of all the objects that have no missing values. Alright, so here I created an X, a vector called X, which is 1, 2, 4 and 5 and missing values scattered about. And then Y is a character vector with also some missing values in it. So I can use the completecases function on both vectors, which will give me a vector that tells me which of the two different vectors, which positions are there that have both elements non-missing. So you can see the first two are both non-missing, the 3rd one's missing, the 4th one is non-missing, the 5th one is missing, and the 6th one is non-missing. So for the both vectors X and Y, I want the 1st, the 2nd, the 4th and the 6th elements. So now when I subset X, I get the good elements of that, and when I subset Y, I also get the good elements of that. So that's how I can look at multiple objects and kind of subset all the missing values out to get the good elements. You can also use completecases to remove missing values from data frames. So here I've got a simple data frame where I'm showing the first 6 rows. As you can see, there are 6 columns to this data frame, so there's 6 variables, and there's some missing values in the ozone variable, and there's some missing values in the solar.r variable. And so all I want are the rows of the data frame where all the values are non-missing, right? So in this example, the rows that I want are rows 1 through 4, and I can use complete cases on the air quality data frame, and I create a logical vector that I called good here. So the logical vector here tells me which rows are complete, and then when I subset out the air quality matrix and take out the first 6 rows, you can see that none of the rows have any missing values in them. So that's subsetting out missing values. And complete cases is very handy function which you use when you have multiple sets of vectors or large data frames and you want to subset all the missing values out. This is just a simple note on vectorized operations in R. I have covered vectorized operations in the previous lesson. So to add a little bit more to that lesson, vectorized operations is one of the features of the R language that makes it easy to use on the command line. It makes very easy to write code without having to do lots of looping and things like that. And so it's kind of a natural thing to have in a computational language. Many other types of languages like MATLAB have this kind of feature. So the idea with vectorized operations is that things can happen in parallel when you, for example, want to do a computation. For example, suppose I got two vectors here, x and y. X is the sequence 1 through 4 and y is the sequence 6 through 9. And I want to add the two vectors together. Now when I say I want to add them, what I mean is I want to add the first element of x to the first element of y, the second element of x to the second element of y, the third element to the third element, etc. So I want to kind of do things in parallel like that. So in other languages you might have to use a loop to do that. So you would loop through each element and kind of add them one by one. But in R you can just use the plus on the two vectors and it will just add them together. So x plus y kind of does what you would expect. It adds 1 to 6, 2 to 7, 3 to 8 and 4 to 9. So you get the vectors 7, 9, 11 and 13. Similarly, you can use the greater than or less than symbols to give you logical vectors. For example, x greater than 2. So well, x is actually a vector of 4 numbers. So which number are you comparing to 2? Well, the vectorized operation compares all the numbers to 2 and it gives you a vector of falses and trues depending on which numbers happen to be bigger than 2. So you can also use greater than or equal to, and that will tell you which numbers are greater than and equal to 2, and the double equal sign test for equality. So it will take each element of y and test to see whether it's equal to 8. And the other kind of arithmetic operations like multiplication and division are all vectorized types of operation. So when you want to multiply or divide, add, subtract the vectors, you can do the natural thing. Just add them together or multiply them together and the operation will be done in parallel. Similarly, you can add and subtract and multiply and divide matrices together. So it's useful to know this because there are different types of matrix multiplication. So I have created two matrices here, x and y. X is the matrix 1 through 4. It's a 2 by 2 matrix, and y is a matrix that's all tens. It's also a 2 by 2 matrix. So if I just do x times y, this is not a matrix multiplication. This is an element wise multiplication. So the first element of x is multiplied by the 1 1 element of y, and the 2 2 element is multiplying the 2 2 element of the other matrix, etc. So each element is multiplied together in parallel. Same thing happens when you do division. This is not a matrix inverse or something like that. This is just dividing one matrix literally element by another. So if you want to do a true matrix multiplication, you have to use the asterisk symbol between two % symbols. That's the symbol for a matrix multiplication. So that's it for vectorized operations for now. You will see these a lot more often later on, but I just wanted to introduce this idea because it makes code easier to write. And for those of you who are kind of used to other types of programming languages, if you have programmed in languages where you cannot do this kind of thing, it's common to kind of reflexively go to something like a for loop or a while loop or whatever it is. But in a language like R, you can just use the vectorized operations to make the code a lot simpler. See you in the next lecture.